morning, students. Welcome to Machine Learning online class. In today's session, we'll be discussing your third chapter of fourth unit, that is reinforcement learning. Under this chapter, we'll be discussing, first of all, we'll see the introduction related to reinforcement learning, what exactly reinforcement learning means. Then we see the learning task. I mean, how the learner, based on what the learner learns over here, we will see that. Then we'll see a concept called Q learning and non-deterministic learning. Then rewards and actions. What are rewards? What are actions? Then temporal difference learning, generalizing from examples, and a relationship to dynamic programming. So all these concepts we'll try to cover in today's session itself. So let's just get into this reinforcement learning concept. So the reinforcement learning, it is a feedback based learning mechanism under this machine learning itself. So why we call this approach as a feedback based approach, in the sense, because under this reinforcement learning, the learner will not have any kind of data. Okay, the learner will be provided with the environment here. Okay, so you can to understand this reinforcement learning, you can take the example of a robot. So when we place a robot in the real world, here the real world is nothing but the domain of the robot. And when we place the robot in the domain, how the robot will act, I mean, on based on what the robot will perform the actions, and how it changes from one state to another state, how it will move in the environment, and how it will perform its designated task in the environment, that are all come under the reinforcement learning concept only. As I said, here the learner, it will not be provided with any kind of data, prior data, historical data. So the learner has to take some actions in the environment, and based on those actions only, it has to learn from the environment. Okay, so here the mechanism, it is semi-supervised learning. Okay, when we say reinforcement learning, it comes under the semi-supervised learning thing. Okay, because we know supervised learning, in the sense, it will be performed with the help of labeled data, and unsupervised learning will be performed with the help of unlabeled data. And this reinforcement learning, it is the combination of those two. Sometimes it go in a supervised way, and sometimes it will go in an unsupervised way. So here we call it as the semi supervised learning approach. Your reinforcement learning, it is the concept of semi supervised learning approach. Okay, quickly we see what we have in this slide. So reinforcement learning, as I said, it is a feedback based machine learning approach. Here an agent learns to, so what he learns exactly, in the sense, which actions to perform by looking at the environment. So whenever we place the agent, here when we are saying agent, it is nothing but the action performer. Okay, the active part of your learning process. Okay, the intelligent part of your learning process is nothing but the agent. So in our robot example, we consider our robot itself as the agent. Okay, so here what the agent learns, in the sense, it will learn the type of actions which has to be performed by looking at the environment. It will observe the environment. Suppose if the robot is moving in the forward direction, let us assume the robot is moving in the forward direction, suddenly a wall comes in between. So what the robot will do, automatically it will changes its path, and it will select some different path to move. Okay, so in that way, changing path by observing the wall is nothing but it is a kind of action performed by, it is a kind of intelligent action performed by the agent. Okay, so hope you understood. So what the agent will do, it will look at the environment. Okay, it will look at the environment, and based on the environmental condition, it performs a suitable action. Okay, so every action performed by the agent leads to a state change. Initially, wherever it is, wherever the agent is, after performing the action, a state change in the environment will occur. Okay, so the agent interacts with the environment and identifies the possible actions to be performed, that can be performed. So that is what I said. Now, it before performing a particular action, the agent will interact with the environment, and based on the environmental condition only, the agent identifies the possible action to be performed. So that is what the reinforcement learning concept is. Okay, based on the environment feedback only, based on the environment condition only, the agent is performing the actions, or we can say the agent is selecting the suitable action to be performed. So that's the reason we call this reinforcement learning as a feedback based approach. Hopefully you understood. So, reinforcement learning addresses the question of how an autonomous agent that senses and acts in its environment can learn to choose optimal action to achieve its goal. So, probably whenever we see an agent in the reinforcement learning, it is going to have some designated task. It is going to have some task to be performed, and we successful completion of the task, we consider it as a goal. Okay, once the agent in reinforcement learning, if it performs the designated task, and why we are calling that agent as autonomous, in the sense it is not under the pressure of anybody, it will work independently by observing the environment. It will act and it will completely work independent of any supervision. So that's the reason we are calling it as an autonomous agent. Okay, hopefully you understood. So how it will act, or how it will perform the actions, in the sense by observing the environment, by sensing the environment. Hopefully you understood. Okay, so its ultimate goal is to achieve the goal states, or we can say to accomplish the designated task. Okay, the agent's ultimate goal is to accomplish the designated task. Hopefully it is clear. So the very generic problem covers tasks such as learning to control a mobile robot, learning to optimize operations in factories, and learning to play board games. So these are some of the examples which we can apply to this reinforcement learning. Okay, the first one, as it is saying, a mobile robot. So I already gave this example to you. The way how a robot works in the real-time environment, it is purely based on reinforcement learning only. Okay, it will perform a particular action. If it is successfully performed, it records that particular action as a successful action. And if it is performing a particular action, and if it is going like a mistake, so then also it will record that action as a mistake, and it will record it as not to repeat in the future, because a mistake bound task, it should be avoided, isn't it? So that's the reason the robot will record that particular action in such a way not to repeat in the future. Hopefully you understood. So a mobile robot, it is a best example for reinforcement learning. We have other examples as well, like learning to optimize operations in factories. As we know, in manufacturing industries or in health sector nowadays, many tasks which are previously performed by the humans, they are automating such type of tasks, and they are replacing such type of tasks with robots. So basically robotic arms, nowadays they are doing surgeries, and in manufacturing industries also, robotic arms they are designing, or they are manufacturing the products, like in automobile sector you can see, or in manufacturing sector you can see many tasks, many operations previously which are performed by the humans, and nowadays they are performed by the robots. Okay, and learning to play the board games. So we have different board games, like your Go game, or your what we call checkers game, or your chess game. All these are examples for board games, and in such board games also, to make an agent to play this board game intelligently, we can use this reinforcement learning. Okay, these are all some of the examples of reinforcement learning. So each time what the agent will do, already I told now, the agent will perform an action in its environment. A trainer, see, as I said, this reinforcement learning, it comes under the semi-supervised. Semi-supervised in the sense, for some actions the agent will supervise, and for some a supervision will be there. A trainer will supervise, and for some action there will be no supervision. That's the reason we call this reinforcement learning as a semi supervised learning approach. Okay, so that's the reason here what they are saying, each time the agent performs an action in its environment, a trainer may provide a reward or penalty. So, based on the action nature, or we can say based on the agent's behavior, in order to perform that task, or in order to perform that action, a trainer may provide a reward. Here we will give some reward to that agent, or a penalty. If it is a successful task, successful result we are getting from the agent's action, we award the reward. And if it is leading to a what we call a failure, an unwanted state, then we give the penalty. Okay, so very simple thing. Reinforcement learning, the agent will perform some task, and if it is leading to the goal state, if that particular task is leading to the goal state, we give some rewards to the agent, so that the agent will repeat that type of task, that type of behavior, because performing a successful action which is leading towards the goal is our ultimate thing over here. So that's the reason whenever an agent is performing a successful task, we award the rewards, we give the rewards. And if it is performing, if the agent is performing an unsuccessful task or an undesirable task, we simply give the penalty. Okay, so for example, when training, here you can see, when training an agent to play a game, the trainer might provide a positive reward when the game is won. If the agent is winning the game, what we are doing, we are giving a positive reward that comes under the reward only, and negative when the agent loses the game. If the agent is losing the game or loses the game, simply we give the penalty, negative reward. Penalty is nothing but a negative reward. And when we give zero, in the sense, if the game goes draw, okay, there is no resulting state. I mean, we are not in a position to conclude that as a winning state or losing state. Then we simply give the result as award as zero. Hopefully, it is clear. See, the primary goal of an agent in reinforcement learning is to perform actions by looking at the environment and get the maximum positive rewards. Always we program the agent in such a way to gain the maximum positive rewards only. So that's the reason, in to perform the maximum positive rewards, what the agent has to do, the agent has to perform the correct actions only, successful actions only, actions which are leading towards the goal state only. Okay, so that's the reason we are saying the primary goal of an agent in reinforcement learning is to perform actions by looking at the environment and get the maximum positive rewards. Maximum positive. Suppose, say, we are at a particular state, and from that state we have three different states resulting. Okay, like this we have. Now this is one state, this is another state, this is another state. So currently we are at this state S1, the agent is at this state S1, and here we have three different types of actions. A1, if the agent is performing A1 type of action from this S1 state, the state will be resulted to S2 state. And from S1, if the agent is performing A2 type of action, the resulting state will be S3. Okay, then if from S1, if the action A3 is performed, the resulting state will be S4. Let us assume like this, we have S1 A1 leads to S2 state, S1 A2 leads to S3 state, S1 A3 leads to S4 state. And when performing this type of action, obviously the supervisor, the trainer, what it will do, it will give some kind of reward. Let us say R1 when it is performing A1 action, and here R2 when it is performing A2 action, and R3 when it is performing A3 type of action. So if the agent from S1 state, if he is performing action A1, he will get R1 reward and the resulting state will be S2. After performing A1 action, the resulting state will be S2. Same way, the agent from S1 state, if he performs the A2 action, the awarded reward will be R2 and the resulting state will be S3. ఓకే, యాక్షన్ పర్ఫామ్ చేసిందంటే కంపల్సరీగా మనకు ఎన్వైరన్మెంట్ స్టేట్ లో చేంజ్ వస్తుంది. ఆ రిజల్టింగ్ స్టేట్ గురించి ఇక్కడ మనం మాట్లాడుతున్నాం. S2 అంటే రిజల్టింగ్ స్టేట్, S3, S2, S3, S4, all these are resulting states, and this is its current state. S1 is its current state. So if it performs the A1 action, the resulting state will be S2, and by performing action A1, what type of awards it is, what type of rewards it is gaining? R1 type of reward it is gaining. So over here, let us assume R1 is greater than, R2 is greater than R3. Like this we have. So which one is the greatest? R1 is the greatest. So always what the agent want to perform when it is at S1 state, it want to perform an action. It always wants to perform an action leading to the highest possible reward, because we said now we trained, I mean we programmed our agent in such a way to always try to get the maximum positive reward. And here we are saying R1 is greater, R2 is greater, R3. So R1 is the bigger one, and how can the agent achieve that R1 reward, in the sense by performing action A1. So if it performs the action A1, the resulting state will be S2 and the gained reward will be R1. So that is the maximum. So always in this type of scenarios, in this type of situations, always the agent from S1 state tries to perform the A1 action only, because that will give us the good positive rewards. Okay, comparatively that will give us the good positive rewards. In such a way, we made our agent behavior always positive by making it to achieve always maximum rewards, maximum positive rewards. We make our agent to behave good. Hopefully you understood. So let's take an example here, that same thing, where the agent has to travel from state E. That is nothing but the center of this diagram. So we want our agent to travel from center of the this particular thing, that is E, travel from state E to goal state G. Here we have goal state. Okay, so when the agent is at E, he can take only one possible action. So from AE, we have here the blockage, so he cannot move from E to B, and he can move in only 4 possible directions, that is towards right, towards left, towards up, and towards down. Only these type of movements the agent can take. No other diagonal movement it is not possible to. For our simplicity, we are avoiding diagonal movement, but in real time the robots can take diagonal movements also. But our easy understanding, we said it can move only in the these 4 possible directions. It can move upwards, downwards, rightwards, and leftwards. Okay, when the agent is at E state, its only possible movement is from E to F. Here you can see it can move only in this direction, because this is the only possible thing. Okay, like this, it can move from here to here. So when the agent is at F, after moving from E to F, it will gain some positive rewards. And when the agent is at F, what are its possibilities? It will have 2 different possibilities. Either it can move in the up direction, or it can move in the down direction. If it moves in the up direction, obviously it is going towards the goal state, isn't it? So there will be positive rewards. Moving towards C will result the positive rewards, and moving towards I, okay, because it is not leading to the goal state. As you can see, after moving I, again it has to move to H, and after H we have the blockage, isn't it? So it cannot move from H to goal state. So moving towards I is a wrong decision. So if the agent if the agent moves in this direction, what we will do? Will supervise that action and will reward the negative rewards, or we can say we give a penalty for such type of action. We'll give a penalty so as the agent will avoid that type of action in future. Currently it has taken that action, we can't avoid it. So how we can avoid that action in future? In the sense, by giving penalties, by giving negative rewards, so that the agent, internally agent will have some memory, and in that memory it will record this action as a wrong action, wrong decision. So in future it will avoid that type of action. So with this simple diagram you can understand the complete working of reinforcement learning. Okay, so here that only they said, when he in the sense the agent, when the agent performs action moving towards I, as it is an incorrect action, for this he will get negative rewards. Okay, hopefully you understood. Whenever he performs a correct action in the environment, he will be rewarded with the positive rewards, and whenever he performs a negative or a wrong action, an incorrect action, so he will be rewarded with a negative reward, so as to avoid that type of action in future. Hopefully it is clear for you. So that only, whenever the agent gets the negative feedback, how it will record that negative feedback thing in its memory, that only they are discussing in this particular point. So whenever the agent gets negative feedback, if it gets the negative feedback, he will understand that he should not follow such path in future. So that is a corrective measure. Awarding negative rewards is a corrective measure in future, for the future. So what we are saying, he will understand, I mean, when he receives the negative rewards or negative feedback, he will understand that he should not follow such path in future. He should not repeat such type of action in future. That is how reinforcement learning works. That is the basic principle, we can say. That is the basic principle for reinforcement learning. So in reinforcement learning, the agent learns automatically using feedback without any labeled data. We are not having, because it is not a supervised learning. So we are saying we don't have any labeled data. And then how the agent will learn without the labeled data, how the agent will learn, in the sense, in this such approach only it will learn. Okay, it will perform some action, and if it is resulting the positive rewards, it will try to repeat such an action in future. And if any particular action is resulting to the negative rewards, negative feedback, he will understand that he should not follow such path in the future. He will understand that he should not repeat that type of action in future. Okay, so since there is no labeled data, so the agent is bound to learn by its experience only. So this is what applying applying a particular action or performing a particular action, and learning from the result of that action is nothing but the experience based learning. And your reinforcement learning is purely experience based. Okay, based on experience only the learning takes place over here. Okay, so reinforcement learning can be used to solve specific types of problems where decision making is sequential and the goal is long term, such as playing games, robotics, and so on. So in this type of domains, the reinforcement learning can be successfully applied. Okay, there are two types of reinforcement learning: positive reinforcement learning and negative reinforcement learning. There is no much difference between these two, positive reinforcement learning and negative reinforcement learning. Both actions can be considered in as a similar approaches, but the reverse of each other. Okay, these two approaches are reverse of each other. Positive reinforcement learning, in the sense, always we try to repeat the positive actions in future, and negative reinforcement learning, in the sense, avoiding negative avoidance of gaining negative rewards. That is what, or we can say weakening the behavior. Okay, discouraging such behavior. What type of behavior? Gaining negative rewards. Okay, we always try to discourage gaining negative rewards or weaken such type of behavior. Okay, so positive reinforcement learning, quickly we read it. It is a recurrence of behavior. Recurrence in the sense again and again repeating. Okay, it is the recurrence of behavior due to positive reward. So obviously, if we are gaining positive rewards by performing a particular type of action, means we try to repeat that type of thing in future also. Okay, so that's the reason, recurrence of behavior due to positive rewards. Rewards increases the strength and frequency of specific behavior. Frequency of specific behavior, ఒక particular behavior again and again repeat అవుతుందన్నమాట. So that's the reason, strengthening the frequency of gaining positive rewards. Okay, gaining positive rewards అనే behavior ని మనం ఫ్యూచర్ లో రిపీట్ చేస్తున్నాం. అలాంటి ఫ్రీక్వెన్సీని స్ట్రెంగ్తెన్ చేస్తున్నాం. హోప్ఫుల్లీ ఇట్ ఇస్ క్లియర్. సో దిస్ ఎన్కరేజెస్ to execute similar actions that yield maximum rewards, giving maximum rewards. Okay, so negative reinforcement learning, here the negative rewards are used as discouraging to weaken the behavior and to avoid it. Obviously, this particular statement only give the full justification to this negative reinforcement learning, what we said. So we always try to discourage or weaken the behavior of gaining negative rewards, and we try to avoid, or we try to minimize the frequency of such type of behavior. Okay, hopefully it is clear. So here another example to make it understand your reinforcement learning. So it is a kind of game, okay, a board game. So what we have here, see the center black brick, whatever you are seeing, it is the complete blockage, or we can say here the agent cannot move. Okay, and this square, a brick with diagonal lines, this is the goal brick. Okay, and a brick with this type of hash type of or color, we call some gray color, we call it as the danger brick. So here the agent can move, but we should avoid such a movement because it is a danger brick. Okay, so let us assume, yeah, quickly read it. In this grid game, the gray tile indicates the danger. Okay, and the black indicates the blockage. Black brick indicates the blockage. Here you have that one, and the tiles with the diagonal lines, this one, diagonal lines indicates the goal. So wherever the agent is in this particular thing, wherever the agent is, our ultimate goal is, its ultimate goal is to reach the goal brick. Okay, goal block. We can, yeah, here it has to come. So positive and negative rewards are simulated in reinforcement learning. So here, whenever it is performing a good action, okay, a positive action, an action leading towards the goal state, we are awarding plus 10 rewards. There is no unit, it is just assume plus 10. Okay, and whenever it performs a wrong, an incorrect action, we are awarding with a negative reward of minus 10. Here it is given. So if it performs a successful action, an action leading towards the goal, we award plus 10 rewards, and whenever it performs an unsuccessful an incorrect action, we reward minus 10. Okay, yeah, here the aim, from where we are starting, the aim is to start bottom left grid. So these are the bottom bricks, these are the center, these are the top. Bottom left, that means from here we are starting. The agent initially will be at this location, and from here it has to start. So obviously, if it moves from here to here, it is a wrong action, incorrect action, so minus 10. So with that, the agent will learn it should not move. Whenever it is bottom left brick, it should not move in the right direction. It will understand in that way. So the only possible move, if it is not moving here, the only possible move is from here to here. So for such move, we obviously award, because it is a correct move, we obviously award plus 10. It cannot move from here to here because it is the blockage. Okay, then from here to here, obviously it is also plus 10, and here to here plus 10, and finally from here to here will give another plus 10, or we can say some greater possible rewards we will give from here to here, so as to avoid moving from here to other state. Okay, once it is reaching the goal state, it has to be stabilized. It has to be stabilized itself over there itself. It should not move from there to any other state. Okay, hopefully you understood. So this is how the reinforcement learning mechanism will work. So here also the same thing. Uh, yeah, here that same thing. Consider building a learning robot. So using this reinforcement learning, we are building a learning robot. The robot or agent has a set of sensors. It will have all over. I mean, how it is going to what we call inspect the environment, and how it is going to observe the environment, in the sense using type of sensors, different types of sensors. The robot is going to have the sonar sensor, the what we call the camera. It is going to have a camera and different types of sensors attached to it. Based on those sensors and the camera only, it will observe the environment. Okay, and based on the environmental condition, it is going to perform a set of actions. Okay, so always from that set of actions, it has to select a particular action which will award maximum rewards, isn't it? Maximum positive rewards. So after selecting that maximum reward gaining action, it will perform that action. And always performing an action onto a particular state will alter the state, or we can say changes the state. Okay. For example, a mobile robot may have sensors such as camera and sonars. Here they have given the detailed explanation with example how a robot will work. A mobile robot may have sensors such as the camera and sonars. Okay, sonars sometimes they will help in identifying the distance between the hurdle in front. If there is a wall, when the robot is moving, if there is a wall in front of the robot, how far that wall is, in order to detect the distance from the wall, it uses the sonars. Okay, and actions, what type of actions the robot can perform, in the sense move, forward, turn. Okay, if the distance is when it is reading the distance between the wall and itself using sonars, and if that distance is say 10 meters, 20 meters, so it can freely move towards that wall, no need to take the turn. And slowly, when it is moving towards the wall, what will happen? Slowly the distance will go less. I mean, the distance will decrease, isn't it? So once it reaches a particular distance, say 0.5 meters or 1 meter, so there it has to take the turn. So if it don't take the turn, then what will happen? Automatically it is going to hit the wall. So obviously, after reaching the minimum fixed distance, it has to take the turn. So that to move forward and turn, these type of actions will come under the mobile robot. Okay, its task is to learn a control strategy. So that type of strategy only, because when it is in its current state, I told you now, when it is in current state, say S, in order to perform a particular action A, so that the state will get changed to S dash, let us assume. So this particular action selection, because we are going to have different types of actions here, not just the one. Here we are going to have some n number of actions. So say suppose A1, A2, A3 and so on AN. So action set, we call it as action set, and we denote it with capital A. We denote it with capital A. And here also, performing A1 results say S1, performing A2 say S2. Such a way, performing AN results the state Sn. So all these are possible states. So S1, S2 and so on Sn, these are all possible states, and we call it this set as states set, and we denote with capital S, states set. So the task over here is to learn a control strategy. A control strategy, usually we denote this control strategy with pi. Okay, so the task is to learn a control strategy pi, which will select the best action from this action state. Okay, whenever the agent is at a particular state S, so how it will changes its states in the sense by performing the correct action, isn't it? The action which will give the maximum possible rewards, and how it will select that maximum reward giving action in the sense by applying the control strategy. So here pi, we can say pi s to a. Pi is a function which will when applied on a particular state results the pi is nothing but control strategy. So when we apply the control strategy on a particular state, what it will result? It will result the best action, the action which will give the maximum rewards. Hopefully you understood. So control strategy, or sometimes we also call it as control policy, for choosing an action. Already I told you now what it will return, what it will result, the action that achieve its goal. Okay, that achieve its goal. So it may be directly giving the goal state, or it may lead towards the goal state, your action. Okay, that type of action only we have to select every time, we have to choose every time, and that selection, how it will happen in the sense by applying the control strategy pi. Okay, okay, let us take an example here. The robot may have a goal of docking onto its battery charger. So whenever the battery goes low, isn't it? Suppose the robot is moving in the environment, and there should be some battery. Okay, all the robots we know, they are battery operated, isn't it? So if the battery goes down, if the battery goes a particular, say below 5%, then immediately what it has to do, the robot has to do, the robot has to charge itself. So what it has to do, it has to docking in the sense, the dock station. For every robot a kind of docking station will be there. డాకింగ్ స్టేషన్ అంటే ఏం లేదు, ఆ డాకింగ్ స్టేషన్ లో వెళ్ళి ఆ రోబో నిలబడిందంటే అది ఛార్జింగ్ స్టార్ట్ అవుతుంది అన్నమాట. ఓకే, ఒక చార్జర్ లాంటిది, ఒక ఛార్జింగ్ కేస్ లాంటిది డాకింగ్ స్టేషన్ అంటే. డోంట్ యూ మిస్అండర్స్టూడ్ దట్ డాకింగ్ with some other meaning. So docking station in the sense, it is a kind of holder for the robot while it is charging. Okay, so charging holder ani kuda cheppochu. So the robot may have a goal of docking onto its battery charger whenever its battery level is low. So idi goal. So ee goal ki successful actions ni perform cheyali. Whenever the battery goes down, a particular environmental state low, the agent has to perform the proper actions or the best actions. So those actions will take the robot to the docking station. So okay, the agent can learn successful control policy by experimenting in the environment. ఈ successful control policy నే agent learn చేయాలి. ప్రీవియస్ కేసెస్ లో మనం ఎలాగైతే కొన్ని కేసెస్ లో బెస్ట్ హైపోథెసిస్ ని, కొన్ని కేసెస్ లో వెయిట్స్ ని, అండ్ ఇంకొన్ని కేసెస్ లో మనం బెస్ట్ ప్రిడికేట్ లాజిక్ ని ఎలాగైతే మనం రీడ్ చేశామో, బెస్ట్ డిసిషన్ ట్రీని ఎలాగైతే మనం ఈల్డ్ చేశామో ఫ్రమ్ అవర్ లెర్నింగ్ పాలసీ, హియర్ ఫ్రమ్ ది లెర్నింగ్ what the agent will learn in the sense, a kind of control policy which will always select the best action when applied on a state. And how it is going to learn that control policy in the sense, by experimenting only. It has to experiment, it has to perform the action and check the awarded reward. If it is positive reward, it will recurrently repeat that type of behavior. If it is resulting to a negative reward, it will decrease the recurrence or decrease the frequency of recurrence of such type of actions. Okay, so hopefully you understood these things. Yeah, this is what just now I have explained. See, if it is at S naught and applying A naught action, it will gain R naught reward, and the state change will occur from S naught to S1. And here A naught we will assume as the best action. Here also same thing, S1 when applied A1, it will go to S2 and gain the rewards R1 likewise. So here you can see agent, what it will do, it will senses the environment. Always the agent is present in the environment, it senses the environment, and based on the environment state, okay, based on its state, it will select a suitable action to perform, and by performing that action it will gain some reward. Okay, that is how this reinforcement learning, the entire setting of reinforcement learning is given in this simple diagram. Okay, so there are some differences between the regular approximation tasks and the reinforcement learning mechanism, because other approaches whatever we observed in our previous examples, they are purely different and different than this reinforcement learning. There we are going to have labeled data or unlabeled data, but here we will have no data at all. Based on the experience only, the reinforcement learning will work, and that experience how the agent will gain in the sense by performing the mistakes, okay, by doing the mistakes. Okay, so delayed rewards, the task of the agent is to learn a target function. So that is what here the target function or the control policy or the target policy is learning this pi only. As I said earlier, pi ni learn cheyali, ఈ pi నే మనం ఏమంటాం కంట్రోల్ పాలసీ అంటాము. అండ్ వెన్ అప్లైడ్ ఆన్ ది స్టేట్, ఓకే, దీన్ని టూ వేస్ లో రాయొచ్చు. ఒకటి పై ఇలా కూడా రాయొచ్చు, ఎస్ గివ్ ఏ ఆర్ ఏ ఈక్వల్స్ టు పై ఆఫ్ ఎస్. సో ఆ పర్టికులర్ కంట్రోల్ పాలసీని మనం ఎన్వైరన్మెంటల్ స్టేట్ పైన అప్లై చేసినప్పుడు మనకు రిజల్ట్ అయ్యేది ఏంటి, యాక్షన్. అండ్ ఈ యాక్షన్ తో పాటు మనకి ఇంకా ఏమొస్తాయి, రివార్డ్స్ అనేవి కూడా వస్తాయి. ఓకే, సో రివార్డ్స్ అనేవి ఒక డిఫరెంట్ థింగ్ ని డిసైడ్ చేస్తాయి. కంట్రోల్ పాలసీ వెన్ అప్లైడ్ ఆన్ ది స్టేట్ will give us the action, best action to be performed, and performing that best action always maximizes the rewards. Okay, so exploration always, reinforcement learning, agent influences the distribution of training examples by the action sequence of chooses. Okay, by the action sequence it chooses what type of actions it is performing, what type of actions it is choosing to perform. Based on that only the entire reinforcement learning will work, because here there is no training examples. Okay, then partially observable states. So sometimes when we are setting up the agent or setting up the robot in the environment, always the environment is not fully observable. Okay, environment ki kuda different natures ఉంటాయి. సో మోస్ట్ ఆఫ్ ద కేసెస్ మనకు ఎన్వైరన్మెంట్ ఎలా ఉంటుందంటే ఫుల్లీ అబ్జర్వబుల్ ఎన్వైరన్మెంట్ ఉండదు. ఫుల్లీ అబ్జర్వబుల్ అంటే ఆల్ 360 డిగ్రీస్ డేటా మన దగ్గర ఉండాలి. అలాంటి డేటా ఒకటే పాయింట్ లో అంత మొత్తం డేటాని మనం మెయింటైన్ చేయలేము, అండ్ దట్ ఈస్ నాట్ ది ఎఫిషియంట్ అప్రోచ్. So always when the robot, let us assume the robot is moving in the forward direction after leaving a particular state. Okay, after leaving a particular state, we don't have that state information any further. ఓకే, ఇలా ఎలా ఉంటుంది, మనం ఫ్రంట్ లో మూవ్ అవుతున్నప్పుడు మనం ఫ్రంట్ గురించి ఆలోచిస్తాం అంతేగాని ఆల్రెడీ గడిచిపోయిన స్టేట్స్ గురించి మనం ఆలోచించాం, ఇజంట్ ఇట్? So as it is not going to have any camera pointing towards back and any sensors in the back, so it will always look for the forward thing only. Okay, so here you can see, for example, a robot with a forward pointing camera. Here they are talking about that a robot with a forward pointing camera cannot see what is behind it. In such cases, it is maybe necessary for the agent to consider its previous observations together with its current sensor data when choosing the actions. So partially observable scenarios lo em cheyali manam ప్రీవియస్ గడిచిపోయిన స్టేట్స్ ఇన్ఫర్మేషన్ కూడా కరెంట్ స్టేట్ యాక్షన్ ని టాలీ చేసేటప్పుడు మనం కన్సిడరేషన్ లోకి తీసుకోవాలి. సో దట్ ఈస్ వాట్ partially observable state. So this is also one of the limitations, one of the difference we can say, which is not there in your other optimization strategies, but it is there in your reinforcement learning. Okay, lifelong learning, and obviously, as I said now, At one instance, it is not possible to cover up the entire environment. So the agent, when kept in the environment based on the environmental condition, it always goes through the learning process, and it will always try to make itself efficient. So the learning of the agent in reinforcement learning, it's a kind of lifelong learning. Okay, always it will perform the actions, and based on that actions it will learn few things. Okay, so how the learning task will be in reinforcement learning, how the learning task will be in a Markov decision process. We call this Markov decision process as MDP. Okay, the agent can perceive a set capital S of distinct states. Already this S I have defined in my previous slides itself. S is nothing but the set of all possible states, S1, S2 and so on, Sn. So that it can perceive అంటే ఆ పర్టికులర్ స్టేట్స్ లో ఏదైనా ఒక స్టేట్ లో ఏజెంట్ ఉండొచ్చు అన్నమాట. సో అలాంటి స్టేట్స్ సెట్ నే మనం క్యాపిటల్ ఎస్ తోటి డినోట్ చేస్తాం. హియర్ క్యాపిటల్ ఇస్ ఎస్ ఇస్ నథింగ్ బట్ the set of all distinct states of its environment. ఓకే, ఎన్వైరన్మెంట్ ఎన్ని డిఫరెంట్ స్టేట్స్ లో ఉండగలుగుతుందో ఆ అన్ని డిఫరెంట్ స్టేట్స్ సెట్ నే మనం క్యాపిటల్ ఎస్ తోటి డినోట్ చేస్తాం. అండ్ అనదర్ థింగ్, క్యాపిటల్ ఏ, ఇట్ ఈస్ సెట్ ఆఫ్ ఆల్ పాసిబుల్ యాక్షన్స్ దట్ ఇట్ కెన్ బి పర్ఫార్మ్డ్. ఆ యాక్షన్ పర్ఫార్మ్ చేసినప్పుడు రివార్డ్స్, మాక్సిమం రివార్డ్స్ వస్తున్నాయా, మినిమం రివార్డ్స్ వస్తున్నాయా, నెగిటివ్ రివార్డ్స్ వస్తున్నాయా అనేది మనం పక్కన పెడితే ఏ అనేది సెట్ ఆఫ్ ఆల్ పాసిబుల్ స్టేట్స్ అన్నమాట. సో దట్ ఈస్ వాట్ క్యాపిటల్ ఏ. సో ఎట్ ఈచ్ డిస్క్రీట్ టైమ్ స్టాంప్, సో ఇక్కడ స్టేట్ చేంజ్ అండ్ యాక్షన్ సెలెక్షన్ అనేది టైం పైన డిపెండ్ అవుతుంది. బికాస్ ద ఏజెంట్ కెన్ నాట్ పర్ఫార్మ్ మల్టిపుల్ టాస్క్స్ ఎట్ ఎ టైమ్, isn't it? The multiple actions at a time. So the agent can perform any one action at any particular time, and that action will result the agent into a different state of the environment. And after reaching the different state only, it can select another action to be performed. Okay, that may result into a different state once again. So that is how all actions will be performed sequentially. So every time we need to consider the time step, at what time it is performing that particular action. We need to take the time step into consideration. We call it as discrete time step, and the agent senses the current state, say ST, అంటే ఒక పర్టికులర్ టైంలో స్టేట్ ఎలా ఉంది అనేది ST డినోట్ చేస్తుంది. దెన్ చూసెస్ అ కరెంట్ యాక్షన్ AT. Okay, AT is nothing but an action, a selected action at a particular time. Okay, at a particular time T, and performs it. Okay, so because all actions will be performed sequentially and all state changes will occur sequentially, so we need to highlight, or we need to mark all these actions and all these states with respect to time. Okay, the environment responds by giving the agent a reward RT. Okay, RT is what? This awarding, or this our awarding function, R is nothing but reward function. ఈ reward function మనం దేని పైన అప్లై చేస్తాం? స్టేట్ అండ్ యాక్షన్ పైన అప్లై చేస్తాం. సో ఎట్ అ పర్టికులర్ స్టేట్, say current state ST, current action AT. So what type of reward it is gaining? To get that RT, we need to apply the reward function. Okay, and obviously after performing that action, there is a resulting state. To get the resulting state, okay, so ST అనేది current state, and next time stamp దగ్గర ఎలాంటి స్టేట్ ఉంటుందో దాన్ని మనం ST+1 అంటాము. And to get that ST+1, we need to apply this state change function delta onto state and action. ఓకే, స్టేట్ చేంజ్ ఫంక్షన్ ని అప్లై చేసినప్పుడు మనకు రిజల్టింగ్ స్టేట్ వస్తుంది. రివార్డ్ ఫంక్షన్ ని అప్లై చేసినప్పుడు మనకు గెయిన్ అయిన రివార్డ్ వస్తుంది. స్టేట్ చేంజ్ ఫంక్షన్ విల్ బి అప్లైడ్ ఆన్ ది కరెంట్ స్టేట్ అండ్ కరెంట్ యాక్షన్, అండ్ రివార్డ్ ఫంక్షన్ విల్ ఆల్సో బి అప్లైడ్ ఆన్ కరెంట్ స్టేట్ అండ్ కరెంట్ యాక్షన్. Okay, hopefully it is understood. Okay, here the function delta and R are part of the environment and are not necessarily known to the agent. Okay, so in a MDP, Markov decision process, yes, delta of st comma at, here the function delta of st comma at, the state change function అని చెప్పొచ్చు దీన్ని. డెల్టాని మనం స్టేట్ చేంజ్ ఫంక్షన్ అంటాము. అండ్ r, that is nothing but a reward function, depends only on the current state and current action and not on the earlier state or actions. Okay, here we consider only the case in which s and a are finite and delta and r are deterministic. Okay, so we can also consider delta and r non-deterministic, but here to make our things simple, we assume them as deterministic only. Okay, so the task of the agent is to learn a policy. Already this thing also I have defined. Learn a policy, and that policy, control policy pi. Okay, control policy pi ni learn cheyali, and always pi s tends to a, or applying pi on s will result a, like this kuda చెప్పొచ్చు. ఇలా లేదా ఇలా టూ వేస్ లో మనం డిఫైన్ చేయొచ్చు కంట్రోల్ పాలసీని. ఓకే, so here you can see, always here the agent has to learn the policy that produces the greatest possible cumulative reward. So elanti control policy undali, control policy which should always produces the greatest possible cumulative reward. And our greatest possible cumulative reward manaku ravalante best action ni manam select chesukovali from the action state, from the action what we call action set. We need to select the best possible action so as to maximize the reward. Okay, to state this requirement more precisely, we define a cumulative value v pi. Okay, previously only pi annamu, but now ultimate goal is to get the cumulative reward, maximum cumulative reward. So ఆ వాల్యూని, ఆ క్యుములేటివ్ వాల్యూని మనం v pi తోటి డిఫైన్ చేస్తాం, అండ్ v pi on st, okay, on the current state, achieved by following an arbitrary policy. A policy, any arbitrary policy. Policies కూడా మనకు డిఫరెంట్ పాలసీస్ ఉంటాయి, దాంట్లో నుంచి ఏదైనా ఒక ఆర్బిట్రరీ పాలసీని మనం ఫాలో అవుతాం. From an arbitrary initial state st as follows. See here, v pi of st. How to calculate this v pi of st? In the sense, rt, current reward, plus this lambda we will take into consideration, lambda rt plus 1, lambda square rt plus 2, and so on. So if you summate all these, you will get this type of formula. Okay, where v pi of st is equals to summation of I equals to 0 to infinity lambda power I rt plus I, likewise. Okay, where the sequence of rewards rt plus 1 is generated by beginning at state st and by repeatedly using the policy, control policy pi, to select action as described by using this formula, control policy at at. In future actions, at plus 1 pi st plus 1, and so on, etc. Okay, so here lambda value will be between 0 to 1, a smaller value between 0 to 1. So always what type of value we need to select? In the sense, maximum value, whatever cumulative rewards for different states, for all states we are getting, from all those possible cumulative values, the maximum cumulative value we will select. Okay, here they have given, see how we can avoid once the agent reaching the goal state, how we can avoid the agent from moving any further. In the sense, simply avoid the highest possible rewards, the highest possible reward you award when it is reaching the goal state, so as to avoid it from moving to any other state. Okay, so here another important thing we have, that is q learning. Yes, so this pi star, whatever we are denoting here, the pi star is nothing but the maximum cumulative reward which we are achieving, and achieving that maximum cumulative reward pi star are what we call the best control strategy, which is leading towards the maximum cumulative reward, it is not always possible to achieve in a single stretch, or we can say in directly. Okay, it is not possible to learn it directly. So because the available training data, whatever we are having, does not provide the training examples, okay, of the form S comma A. Instead, the only training information available to the learner is what type of rewards, immediate rewards, it will gain after applying a particular action. Okay, to the respective state, what type of actions, available actions possible, and if it applies a particular action, what type of reward it will gain. Only that type of information is available. So giving this kind of training information, it is easier to learn a numerical evaluation function defining over states and action, then implement the optimal policy in terms of the evaluated function. The agent should prefer, yeah, when how it will select. The agent will select the state change. In the sense, whatever state change is giving maximum cumulative value, that is nothing but V star S, maximum cumulative value, the agent tries to select that particular state change only. Suppose if we are going for a state change from S1 to S2, which is giving us the maximum cumulative reward, than moving from S1 to S3. So obviously we select the cumulative reward or cumulative value moving from S1 to S2 only. So always whatever state is giving the maximum cumulative value, that only will be considered. Here you can see that one. If at all S1, a particular state, is giving a greater cumulative value than a particular state S2, so always S1 will be selected. So that is what this particular equation will give. There is a Q function is also there that you can go through. Okay, for this some kind of derivations we have here. The Q learning algorithm. Yeah, this is your Q learning algorithm. So select an action A and execute it, receive immediate reward R, observe the new state S dash, update the table entry for Q of S comma A as follows. So every time we need to update the Q value. We are going to maintain the Q value for all possible states from the current state. Okay, and in that matrix, in that graph, we will maintain the Q value, and based on the Q value only, we will select the particular action to be performed or particular state change to be occurred. Okay, here you can see this illustrative example they have given. So here we have 5 rooms. Okay, 5 rooms we have, and all rooms are labeled from 1 to 5, actually 0 to 4, and all outside, because when we have 5 rooms, outside area also we need to consider as a state, and that state is labeled with 5, as you can see here. So this is our room 1, this is room 2, room 3, room 4, this is room 0, and this is outside thing is 5. They have denoted with 5. So suppose we have 5 rooms in a building connected by doors as shown in the below figure. So every room, it is having some doors, and that doors will give us the movement between the rooms. We'll number each room from 0 to 4. Here each room is numbered between 0 to 4, 0 through 4. The outside of the building can be thought of as one big room, that is 5, room 5. Notice that doors of 1 and 4 leads into the building from room 5 outside. So for from room 1 we have a door which will move us outside, and from room 4 also we have a door which will take us the outside. Okay, so solution, convert the building into a state diagram. So what we have to do, we need to convert the building, complete building into a state diagram, state and actions, where each room is represented as a state, this circle as a state, and the door is represented as an action, this particular mark in this case. So here we have a door between 1 and 5, 1 and 3. So moving, getting into that door, coming out of that room is possible through that door. So if he comes out of room 1 using this particular door, it will enter into room 3. If it comes out of the room 1 using this particular door, it will enter into outside. It will come out of the room. So our intention, our goal state, we assume wherever the agent is inside that building, it has to come out of that building. The agent has to come out of that building. So outside of the building, we mark it as goal state. Okay. So in the above, 0 through 4 and 5 are states. Between the states, there are actions represented by arrows in the diagram. That is, the agent can move from state 0 to 4, 4 to 0 by performing some action. Similarly, other states and actions can also be explained. Okay. So how the agent is moving between those rooms, it is represented. So our ultimate goal is what? We have to come out of the building. So if the agent is moving from 1 to 3, yes, 1 to 3, if he is moving, so it is the agent is not entering into the goal state. So we mark it with 0. And whenever a particular action is resulting the goal state, there only we mark that state as, we mark that reward as 100, and all other rewards will be 0. See, from 1, if he is taking this particular door, the agent is coming out of the room, so we are awarding the maximum rewards, that is 100. And if he selects this particular door, it is not reaching into the goal state, so we mark it, we award over the 0 rewards likewise. Okay. So the goal is, we need to initially we need to make our assumptions, our rewards like this, and afterwards for every possible action we will try to calculate the cumulative reward value. Okay. How to calculate that cumulative reward value? In the sense, using this particular formulae only. Here they have given the formulae. Using this particular formulae only, we try to calculate the reward value for all the particular actions. So after calculating, see, for that reward matrix we will maintain. Okay. So wherever we have the reward as 100, that 100 we will mark, and wherever we have the reward value 0, that 0 we will mark, and wherever we don't have any door in between, see here, to move from 1 to 2, do we have a direct door? No. So what we do, all such cases we represent with -1. If there is no door in between any two rooms, in the sense, we mark it with -1. So moving 0 to 0, no door, not possible. Moving 0 to 0, it is an undefined case, so we make it as -1. Here you can see that one, here -1. And moving from 0 to 4, there is a way. 0 to 4, 4 to 0, there is a way. So what we do, 0 to 4, it is 0, and 4 to 0 also, it is 0. You can see. Okay. From 1. Can we move 0 to 1 directly? Not possible. See here, 0 to 1 directly, it is not possible. -1. Same thing, 1 to 0 also, -1. It is not possible. So hope you understood how we made this reward matrix. Hope you understood. Whenever there is a direct transition possible between any two particular states, direct transition possible means we have given the reward value, whether it is 0 or 100. And if it is direct transition, if it is not possible, we simply made it as -1. See, from room 1 reaching the outside, it is possible. If you move from room 1 to 5, it is the agent will come out of the building, so it is a positive, it is reaching like a goal state thing, so it is a positive reward, and we are giving 100 positive reward. See here, 1 to 5, if the agent is moving, we are awarding as 100. Same thing from 5 to 5, because there is a self transition is also possible. So 5 to 5 is also 100, 4 to 5 is also 100, and 1 to 5 is also 100. Hopefully it is clear. And using that type of reward matrix, we will calculate the Q matrix. Okay, and in using that Q formula only. Okay, apply that formula, this particular formula, and calculate the Q values for all the possible states here. Okay, so how we calculate, in the sense, here they have given the explanation. Okay, from state 1 to 5, 1 to 5, for this particular thing they are calculating the Q matrix value, and we got 100, that value as 100. And for other state also they are calculating the Q matrix value, here they have given the explanation, and we got the 80. So what state they are calculating? 3 to 1 they are calculating, 3 to 1, 3 to 1, and we got 80 as value. Here you can see that 3 to 1, 80 value we got, that 80 value they keep. Okay, only 2 3 you have to calculate, and remaining all you can keep like this. For all other for entirely for all the possible states, the Q values they have given like this, and that Q values you can represent over here, and based on the Q values, now the agent can decide where to move. Suppose if the agent is at 3, okay, he can move in this direction or he can move in this direction, likewise he can decide. Okay, so with this, hopefully you got some idea on reinforcement learning. Already it is 1 hour elapsed, so I'm stopping the lecture over here. So hope you got some idea on reinforcement learning, how it will be performed. Some non-deterministic rewards and actions, some theory part is there that you can go through, and temporal difference learning, that also you can go through after understanding the Q learning and after understanding the reinforcement learning process. These concepts, these theory concepts, you can easily go through and you can easily understand. Okay, thank you, students.